Welcome to Pratham Science Academy classes, and we are about to start with the numericals of force and laws of motion for class 9th. For this question, it's given that a truck starts from rest. So whenever an object starts from rest, initial velocity has to be 0. And it rolls down a hill with constant acceleration. So it rolls down a hill with constant acceleration, which is not known. So let's put a question mark and the distance. So distance is denoted by s, which is equal to 400 meter, and time is 30 seconds. We have to find the acceleration. And to find the acceleration, we are going to use the equations of the motion. The first one is v square minus u square is equal to 2as. The second one is, so the first is v is equal to u plus at. The first one is v is equal to u plus at. We are not going to use this because the final velocity is unknown. So we are not going to use this. Let's come on to the second one, that is s is equal to ut plus half at square. We can use this because distance is known, initial velocity is known, and time is known. We can easily find out acceleration from here. So let's write down this equation of motion, which is equal to s is half at square, and the distance is 400 meter. Initial velocity is 0 into time is 20. Half into a into time is 20 square. So this is 400. This term becomes 0. So this is half into a into 20 square is 400. So 400 and 400, we can divide that. So acceleration is 2 meter per second square. Now the acceleration is done. We have to find the force acting on its mass, that is 7 ton. So we know that 1 metric ton is equal to 1000 kg. So 7 tons would be equal to 7 into 1000. That is equal to 7000 kg, and we have to find the force. So force is equal to mass into acceleration. Mass is 7000 into acceleration is 2. So that is, and the unit of force is Newton, so this is 14,000 Newton. So with this, we are done with question number 5. Do like, share, and subscribe. Thank you for watching. Okay, for question number 6, it's given that a stone of 1 kg is thrown with a velocity of 20 meter per second. So mass of stone is 1 kg and initial velocity is 20 meter per second. It's thrown across the frozen surface of a lake and it comes to rest. So if it comes to rest, that means the final velocity is 0. After traveling a distance of 50 meters, the distance is 50 meter. We have to find the force of friction between the stone and the force of friction. Whatever the force is, its mass into acceleration. That means we have to find the acceleration. And for that, we are going to use one of the three equations of motion. The first one is v is equal to u plus at. The time is not given, so we are not going to consider this. Let's consider the second one or the third one. V square minus u square is equal to 2as. This will work for us because v is known, u is known, and distance is also known. So v is 0, u is 20 meter per second, and acceleration has to be calculated. Distance is 50. So this is minus 400, which is equal to 100 into a, and this gets cancelled. So this is minus 4, and acceleration is equal to minus 4 square. Now we have to find the force of friction. So the force of friction is mass into acceleration. Mass is 1 kg, acceleration is negative 4. So this is negative 4 Newton. And negative sign here indicates that the force of friction is opposite in which the stone is going. So let's say if this is lake, and if we have thrown a stone in this direction, so the force of friction is in opposite direction. So that's why we have this negative sign. So with this, we are done with question number 6. Do like, share, and subscribe. Thank you for watching. Okay, for question number 7, it's given that 8,000 kg engine. So this is the engine, and it weighs 8,000 kg. It pulls a train of 5 wagons, 1, 2, 3, 4, and 5. So these are the 5 wagons, and each of them measures 2,000 kg. So the total weight of all the 3 wagons will be 5 into 2, that will be 10,000 kg. Now they are moving along the horizontal track. Train engine pulls in this direction, and the force of friction is in opposite direction, is 5,000 Newton. And engine exerts a force of 35,000 Newton. We have to find the net accelerating force. So the net accelerating force would be the difference of these two. So net accelerating force is equal to, this would be 35,000 minus 5,000 Newton, which will give us 30,000 Newton. So this is the net accelerating force, which is, okay, sorry, it exerts a force of 40,000 Newton. So this is, so this is 40,000, and the net accelerating force would be 40,000 minus 5,000, which would be 35,000 Newton. Now we have to find the acceleration of the train. So acceleration of the train, we can calculate it from the formula F is equal to m into a, because we know the force, which is 35,000. Now the mass would be the total mass of the train, which consists of an engine and a wagon, 5 wagons, so 8,000 plus, and 5 wagons of mass 2,000 each will give us 8,000 plus 10,000, which is equal to 18,000 kg. So this is 18,000 into acceleration is equal to 35,000 divided by 18,000, and which will be 35 by 18. So 35 by 18, if you calculate this 35 by 18, so this would be equal to 1.944 meter per second square. Okay, so with this, we are done with question number 7. Do like, share, and subscribe. Thank you for watching. Okay, for next question, it's given that an automobile vehicle has a mass of 1500 kg. Must be the force between the vehicle and the road, that is the force of friction, if the vehicle has to be stopped with the negative acceleration of 1.7 meter per second square. So it's a simple one. We are just going to use the formula of the force. Mass is 1500 kg. Acceleration is in motion, so this is negative 1.7 second square. And we know that force is equal to mass acceleration. So that should be 1500 into minus 1.7 Newton. And this 1500 into negative 17, that should give us 2550 Newton. So this is 2550 Newton, and the negative sign shows here that this is the force of friction between the tires and the road. So you can see that the negative sign shows that it is the force of friction between the tire and the road. Okay, so with this, we are done with this question. Let's move on to next one. Thank you for watching. For the next question, it's asked what is the momentum of an object of mass m moving with velocity v? And we know that the momentum is denoted by p, and it is the measure of the product of it is measured as a product of mass and velocity. So the correct option is option D. Thank you for watching. Let's move on to the next one. Okay, for next question is given that with using a horizontal force of 200 Newton, we intend to move a wooden cabinet across a floor at a constant velocity. So this constant velocity means that the acceleration is zero because acceleration is the rate of change of velocity. So if the velocity is constant, that means that the acceleration is zero. Now, because the acceleration is zero, so the net force will also be zero because we know that force is equal to mass into acceleration. And here the acceleration is zero, so mass cannot be zero, so that acceleration is zero. So that means m into zero is equal to zero. So our net force on the object, or we can say that the total force on body is zero. So let's say, so this is the total force which is equal to zero. Okay, now, now the total force, what would be the total force on the body? So if a body is moving with the constant velocity, so if we have applied the force, so there are two types of forces. One is the force that you have applied, and next is the force of friction. Let's say it's a small f. So the total force is the force on body plus friction. Force on body that we apply, and friction is in the opposite direction. So force of body plus friction will be the total force that is equal to zero. Now, the force on body is given that the force on the body is this is the total force. Now, the force on the body is given as 200 newtons. So this is 200 newton plus friction is equal to zero. So the frictional force is equal to negative 200 Newton. If we take this to the right hand side, and the negative sign indicates that it's in the opposite, its direction is opposite to that of the motion. So the force of friction is negative 200 Newton. So with this, we are done with this question. Let's move on to the next one. Thank you for watching. Okay, for next question is given that there are two objects of mass 1.5 kg each. So there are two objects of mass 1.5 kg each, and they are moving in same straight line but in opposite direction. So they are moving in the opposite direction. Let m1 be the mass of the first object, and m2 be the second object. Let u1 is the initial velocity of the first object. Both are moving with the same velocity 2.5 meter per second, and u2 be the initial velocity of the second object, which is so because these velocities are in different directions, so let's put a negative sign here. And so they are moving in the opposite directions, they combine and stick together for it's given that stick together, and now this is a combined object, and now they are moving with the velocity after collision. So let's say the velocity after collision is v. So let's find out the total momentum before collision. We are going to use momentum. So total momentum before collision would be the momentum of the first object plus momentum of the second object. So both have same mass, that is 1.5, and same velocity, but are moving in opposite direction. So I'm going to give one of the velocity a negative sign for the opposite direction. Okay. And let's calculate this. So in this case, you can see that I can write it as 1.5 into 2.5. This negative sign, I can put it here. And these are both the same values, but with opposite signs. So these gets cancelled and the total momentum before collision is zero. Now the total collision when the bodies stick together will be m1 plus m2. Let's say this. So this is 1.5 plus 1.5, which is 3 kg. This is 3 kg. Okay, so momentum after collision is equal to m into v, where m is the total mass, which is 3, and v is the final velocity. And according to law of conservation of momentum, we know that law of conservation of momentum says that the momentum is conserved, that is initial momentum is equal to final momentum of the system. So the initial momentum is 0. 0 is equal to the final momentum, which is 3 into v. So velocity after collision will be, because this is final velocity is equal to, that is after colliding they will stick and will come to rest, because these are of the same mass and moving with the same velocity but in opposite directions. Okay, with this we are done with this one, and let's move on to the next one. Do like, share, and subscribe. Thank you for watching. A a hockey ball of mass 200 gram is traveling at 10 meter per second, is struck by a hockey stick so as to return it along its original path with a velocity of 5 meter per second. So the mass of the ball is 200 gram, and let's convert it to kg. So 200 has to be divided by 1000, which is equal to 0.2 kg. Okay, so it's traveling at 10 meter per second, is struck by a hockey. So before hitting, okay, so the velocity is 10 meter per second, and we have to find the change of momentum. So here let's calculate the initial momentum, that is before hitting, and we know that momentum is given by mass. For the its initial velocity, mass is 0.2, velocity is 10, so that is 2, and the units of momentum are kg meter per second. Okay, after hitting, the ball change its path, that it will come or go in some, and here the, let's take it as final velocity is 5 meter per second, and because it's given that along its original path, that is if it's moving this way, so after hitting it will move in the opposite direction but in the same path. It's given that it's returned along its original path, so we will take this velocity as negative for the opposite direction, and this is our final momentum. So final momentum is once again mass into final velocity. Mass is 0.2, that is 0.2 into -5, which is equal to 1 kg meter per second. we have to find the change in momentum. And we know that it's a final value minus initial value. And if it's the change in momentum, it has to be final momentum minus initial momentum. So this is final momentum minus initial. That's in the respective values, which is 2 minus 1 kg meter per second, and that is equal to 3 kg meter per second. Okay, so with this we are done with this one. We have to calculate. We were supposed to calculate the change of momentum occurred in the motion of the hockey of the ball. Let's move on to the next one. Thank you for watching. Okay, for the next question, it's given that a bullet of mass 10 kg is traveling with a velocity of 150 meter per second and strikes a stationary wooden block. Let's say this is the wooden block, and bullet of mass. This is a bullet, and mass of the bullet is 10 gram. This is traveling towards the block with a velocity of 150 meter per second. Let's convert this velocity. That should be equal to 0.01 kg. Now this bullet penetrates the or strikes the wooden block and comes to rest. So that means that the final velocity is 0. Let's say the bullet is here now, and its final velocity is 0 because it comes to rest. V is 0. We have to find the distance of penetration of the bullet into the block. That is, we have to find this distance of penetration into the block. So mass is 0.01 kg, initial velocity is this, and the final velocity is this. And it's given that it comes to rest, and the time is 0.03 second. So let's use the first equation of motion and find the acceleration first, because to calculate the distance, we have to find the acceleration first. So v is 0, initial velocity is 150 plus acceleration, and time is 0.03. So acceleration here, this comes to the left hand side, which is negative, has to be divided by 0.03. So the acceleration is negative 150. The two zeros, the two decimal points are to be removed. So it's 150 divided by 3. So this is 5,000 meter per second square. So the acceleration is negative 5,000 meter per second square. Okay, so we have got the acceleration, and we have to calculate the distance. So let's use another equation of motion, v, which is v square minus v square is equal to 2as. Final velocity is 0. Initial velocity was 150. So this is square of 152 into this is negative 5,000, and s is the distance that has to be calculated. So this is negative 150 into 150 equal to this is negative 10,000 into distance. So negative 19 gets cancelled. 2 zeros them off, and s is equal to 15. 15 into 15 is 225, has to be divided by 100. So that is equal to 0.25. So this is the distance of penetration by the bullet, which is 2.25 meter. And at last, in the end, it's asked what is the force exerted by the wooden block on the bullet? The force exerted on the wooden block by the bullet, this is equal to force is equal to mass into acceleration. And here the mass is 0.01 and acceleration was negative 5,000 meter per second square. So the force exerted is negative 50 Newton. This is the force exerted where negative is for the direction, and if you have just take the magnitude, you can just write it as 15 meters. So F force is equal to 50 Newton. This is the magnitude of force exerted by the bullet on the block. All right, so with this, we are done with this one. Do like, share, and subscribe. Thank you for watching. Okay, for next question, it's given that an object of mass 1 kg is traveling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. So let's say this is an object of mass 1 kg and let's this be m1 and it's moving in a straight line with a velocity of 10 because v1 is equal to 10 meter per second. And okay, so this is stationary wooden block that initial velocity is 0 and that m2 be its mass that is 5 kg. So this is moving and it collides this. They are both in the straight line. Then they both move off together in the same straight line. So calculate the total momentum just before the impact and just after the impact. So momentum before impact. So this is a system of this two bodies. So momentum before impact is the momentum of the first body plus momentum of the second body. Mass is 1, its velocity is 10, mass is 5, initial velocity is 0 because it's stationary. So here the momentum before impact is 10 kg because this is equal to 10 plus 0 which is 10 meter per second. Okay, now it's given that both collide in sticks. So that means now this object is sticking to this object and here the combined mass, total mass will be the mass of both the two objects. Mass of the first object is 1 and the second object is 5, so the total mass is 6 kg. And they are moving with the combined velocity, let's v. So momentum after impact, that is equal to m into v, and here the combined mass is 6. So this is 6 v kg meter per second, where v is the combined velocity of both the objects after the collision. We have to calculate the velocity of the combined objects. So using according to law of conservation of momentum, initial momentum is equal to final momentum of conservation of momentum. The initial momentum is 10 kg meter per second. So 10 is equal to 6 v and v is equal to 10 by 6 which is equal to 5 by 3 meter per second. So this is the final velocity of the combined objects. Okay, so momentum collision and momentum after collision because we know the initial momentum is equal to final momentum, so both will remain the same, and we have to find the combined velocity of the both the objects momentum before collision. Total impact is also 10 kg meter per second, and after the impact it's also 10 kg meter per second, because according to the law of the when we are using the law of conservation of momentum, we have calculated the velocity of the combined object as well, which is 5 by 3 meter per second. With this, we are done with this one. Do like, share, and subscribe. Thank you for watching. Okay, for next question is given that an object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second. That is, initial velocity is 5 meter per second and final velocity is 8 meter per second, and the time is 6 seconds. So we have to find the initial and the final momentum. So initial momentum will be the product of mass into initial velocity, and the final momentum will be mass and final velocity. So this is m into u. M is 100 and u is 5. So 500 kg meter per second, and then the final momentum is mass into velocity, that is 100 into v, that is 8. So this is 100 kg meter per second. This is the initial and the final momentum. We have to calculate the magnitude of force, and according to Newton's second law, the force is the rate of change in momentum. Change in momentum is final momentum minus initial momentum by time, and here the mass is common, so m into v minus t divided by t will give us the force. Mass is 100, or rather we can just put in the value. So this is 500 minus 8 is 6. So this is minus 300 divided by 6, which is equal to negative 50 Newton is the force. Okay, so here it's not negative. Final momentum is 800 minus 500. The time is 6. So this is 300 divided by 6. That is equal to 50 Newton. This is the magnitude of the force exerted on the object. Should you like, share, subscribe? Thank you for watching. Okay, for next question is given that how much momentum in a dumbbell of mass 10 kg. So mass is 10 kg. It transfer to the floor if it falls from a height. So that means the initial velocity was 0, and it falls from a height of 80 centimeters. So this is the distance covered, which is equal to 80 centimeter. Let's convert it to meter. 80 divided by 100, that is 0.8 meter. Okay, and acceleration is downward. That has to be, it's given that it has to be 10 meter per second square, and because we have to find the momentum, and momentum is a product of mass and velocity, that means we have to find the velocity before it touches the ground. So let's use the equations of the motions, and we have three equations of the motions. So we are going to use the v square, the one with the distance. So v square minus u square is equal to 2as. So has to be calculated. U is the initial velocity, which is 0. 2 into acceleration is 10. Distance is 0.8. So v square is equal to 10 is 20 into 8 is 0.8 is 16. So v is 4 meter per second, and it's positive because it's in the downward direction. Now we have to find the momentum, and we know that momentum is given by mass into velocity. Mass of the dumbbell is 10 kg, so this is 10 into 4, which is equal to 40 kg meter per second is the momentum of the dumbbell. Okay, do like, share, subscribe. Thank you for watching.